Right, we have to start our new chapter today, which is number systems, which is going to be kind of easy lesson. And actually, along with the number systems, I'm going to discuss the next one, which is logic gates. And if you are right, if you are good in this, we can finish quickly, right? Okay, so first of all, you should know why these number systems are important in the computer. Right. Actually, we discussed this previously. Also, we discussed number data represented in the computer in the format of binary. Data represented in the computer in the format of binary. Actually, we discussed that previously. In case if you cannot remember, so please refer to this one. It's data representation. Right. So this is what happened in the computer. So this is actually kind of lesson there in the O-level ICT, but still, if you cannot remember, I would like to remind this again. Right? Data representation, basically representing means you use something to actually on behalf of some other thing. For an example, okay, let's say there's a meeting and all students are asked to participate to the meeting. And so maybe you are not well, so your parent decide to participate on behalf of you. So we call your parent is representing you, because it's not you, right? It's not you. Your parents is representing you. On behalf of you, your parent has participated. So that is called representation. So that is not the same, right? Even though we in the machine language we call that 1 and 0, that is not actually 1 and 0. That is just a representation. Understood? Because in wires you can't send.
Yes, sir.
Yeah, in wires you can't send ones and zeros. So basically it's just a representation. So this representation can be done for these things. So for an example, presence of voltage can be represented using 1. Or on can be represented using 1. Present can be represented using 1. That is done in school even. So when marking the attendance. And high voltage or 5 voltage can be represented using 1. And you can, so north pointed magnetism, you can represent it using 1. And burn place, we call pit or burn place in CD or DVD. Burn place in CD or DVD, we usually call pit, so can be represented using 1. Yes can be represented using 1 here. So on the other hand, absence of the voltage, off, absent, low voltage, 0 voltage, south pointed magnetism. So this can be interchanged, right? So one can say south pointed magnetism is 1 and north pointed is 0. One can say 0 volt is 1 and 1 volt is so 5 volt is 0. Likewise, this can be interchanged because only 2 status, nothing else, no value there, only 2 status. And in the other hand, the burned, so here unburned place in a CD or DVD, so can be represented using 1. Sorry, 0. If this is 1, this will be 0. If this is 1, this will be 0. So likewise, so these things can be represented. This is called data representation. Basically, in wires we have voltages. In wires we have voltages. So in the string you can say absent and present. In the string you can say it's absent and present, or on or off. In the string, on off. In wires, high, low voltages. In magnetic discs, it is magnetism. In a optical disc, it is burned, unburned. So light, effects of lights, effects of laser light. So if laser light is on, CD will be burned. If laser light is off, CD will remain unburned, right? So that is what data representation is. If you want, if you cannot remember the stuff, just take a photo, and even the power button, you can see this 1 and 0 symbols indicating the 2 status. Just take a screenshot. So in case if you cannot remember, you have to write down this in your book. Okay. So any doubts up to now?
No, sir.
Right, okay. So here, so let's move forward. Let's move. So this is, you can see in the stream, the left side, you can see stream. So there's a picture, but that picture is not really meaningful, but let's assume this is a part of picture. And in this picture, so you can say one, so let's say, so these are the pixels. Pixels means the smallest stream unit. So that is similar to a LED bulb, which is similar to a LED bulb. Let's say, so when LED bulb is on, it's white color. When LED bulbs are on, it's white color. And when LED bulbs are off, it's black color, no color, or the black color. So then if you zoom area of this image, small part of this image, you can tell these on bulbs are 1 and off bulbs are 0. That is how representation happened in an image. So basically, we are not going to use pure binaries, because if you use pure binaries, it's really lengthy. The pure binary is a lengthy one. But you know that there are two other number systems which can summarize the binary. What are they? There are two other number systems which can summarize binary. What are these number systems? Yes? Any idea?
Sir, could you repeat the question?
Sorry?
Could you repeat the question once again?
Yeah, there are number systems. There are two major number systems which can summarize these binaries, which can write abstract version or abstract or summary version of this binary. What are these two number systems? Yes?
So octal and hexadecimal.
It's octal and hexadecimal. How you can summarize in octal and hexa? If you write 3 by 3, you will get octal. If you write 4 by 4, you get
hexadecimal.
Hexadecimal, right? So here, see, this is a lengthier binary. But if you take 3 by 3, the first tree, it's 0. The second tree, it's also 0. 0, 0, 1 means 1. 1, 1, 1 means 7. 1, 1, 1 means again 7. 1, 0, 0 is 4. And 0, 0, 0 is 0. And again 0, 0, 0. So this is lengthier to write. But this is a short version. Octal. This can be further summarized. This can be further summarized using hexadecimal. So you can see this one. 0, 0, 0, 0. Then 0, 0, 0, 0. So 0, 0, 0, 0 means 0. This is also 0. Then 1, 1, 1, 1 means F. Again 1, 1, 1, 1. F 15. Again these zeros. So then you can see it's only 1, 2, 3, 4, 5, 6 digits. So likewise, computers in the representation, that's why we need octals and hexadecimal, not for the mathematical. So you might think this is for mathematical calculation, this is for the conversion. So rather than conversion, yes, that is for conversion, absolutely. So for sure it's for conversion, but the thing is, rather than that, so there's a easy pattern-based conversion. So where computers are really interested to identify the pattern and represent the numbers, it can easily convert. But so let's say if you want to convert this to decimal, then that is not easy. Because in this decimal, you can't write 3 by 3 or 4 by 4. What you have to do, you have to take the bit value, multiply by the digit value, positional value, you have to multiply by the digit value and add it. So that is complex. For the computer, it will take more time. තියෙන්නේ දෙකේ බින්දුවෙනි බලය දෙකේ එක්වෙනි බලය දෙකේ දෙවෙනි බලය likewise 2 to the power 0 2 to the power 1 2 to the power 2. So then take the digit value and add that. So that is too heavy, so it takes time. But so if you have octal table and hexadecimal table, you can, the computer can easily refer to that table and just 000. It's 0 in the table. 000, it's 0 in the table. 001, it's 1 in the table. Likewise, it can easily convert in between these number systems. That's why computer prefer these number systems. But unfortunately or fortunately, I don't know, we can't go and ask, we can go and ask like if or A8 amount of sugar from the shop. Can you give A8? Can you give me what is the ticket price? It is A10 or A10. You can't A4. Likewise, you can't call. Right? Because we are using decimal number systems. That is the convenient way for us. So therefore, this data representation focuses converting the whatever natural to the human beings to the computer format. So whatever natural to us is an image. So this is how we see pictures. But for computer, there's a different representation. That is this binary representation. What is good for us is music. But for computer, it convert this. This will be taken as a signal, and that will be divided into the equal time interval, which is called sampling. We will learn this in networking, right? So this will be divided into the samples, equal intervals, and then take the value. These are the values. The values are then represented using binaries, and this is the binary signal. Analog signal, you divide it in equal time intervals, take the value and write it in binary, and this is the signal which is to be written in a CD or DVD or hard disk, or which is to be sent in a wire. So computer prefer this version, whereas we like to listen music. So computer prefer this version of matrix, whereas we like to see images. We like to see videos, but computer still prefer this version. So we like to see numbers, but computer prefer these versions of numbers. So that is the gap between the gap between us and computers. So we have to represent our formats in computers format, and computer must do the reconverting of its format to our format to display in the screen or output in a printer or output in a speaker. Right, that is the thing, and that is why we are learning number systems. I think now you have an idea why we are learning number system. Now, in addition to that, characters. So for computer, so there are nothing called characters. So computer has a representation method, that's all. So I think you learned this in O-level ICT, but in case if you forget, let me remind this as well. BCD or binary coded decimal, which is a 4-bit representation methodology. Okay, do you need to take a screenshot of this? Quickly take that. This is how images are represented.
Okay, sir.
Okay. So I always tell that this is O-level ICT lesson, right? But anyway, so why I'm doing this, because we need good background, and then only we can learn this. Otherwise, it's not meaningful, right? Okay, this is how sounds are represented. This is how sounds are represented, or waves are represented. Okay. And so this
Should we
is
take that or no need, right?
sorry,
The previous one, no need, right?
which one?
That on the top, that sound thing, analog digital.
So you have that in your networking part.
Ah, okay.
So if you don't need that now, you can forget, it's okay. But you have everything in your network. So that part is there in the networking syllabus. Okay, character representation. So character representation means basically how this alphabetic thing and numbers are represented, which are there in the keyboard. Keyboard numbers and symbols and data. So initial mechanism to represent character was introduced by IBM, International Business Machines, and they were pioneers, kind of pioneer people. So in the competition of developing the personal computer and computer. So initially you can, I think in the computer history, we learned IBM 704. So supercomputers, those things were introduced, mainframes introduced in the history. So, and with that, so, dividing and multiplying. Computers don't like that. It doesn't like dividing and multiplication. Therefore, this is kind of a table. So BCD is a kind of a table which has 4 bits. So maximum it can go for 2 to the power 4, which means 16 symbols. And this is how symbols are represented, 0 to 9. So this is basically used for numbers. So why this is done? Because when you store this kind of thing in a program, in a software, or in a data structure, so when computer see a number like 958, so it will refer to the table. 9 means 1001, and 5 means 0101, and 8 means, okay, this is not binary to decimal or decimal to binary conversion, right? So don't confuse with that topic. Binary to decimal conversion and decimal to binary conversion is a mathematical process, but this is like a logical process. There's a table, you just refer to the table and represent. So make a then when you see a number and asking to give the binary value of this, you are trying to do the same, but that is not correct. This is representation, but giving a decimal and asking the binary value is mathematics. Don't confuse, right? So in your examination, you might ask both questions. By giving a decimal number, please write the binary number of this. Then you have to divide. Divide by 2, write the remainder, divide by 2, write the remainder, divide by 2. Likewise, you have to divide and get the number. But so by giving a number, asking the BCD version, BCD representation of this, then no division. Then you have to have this table somewhere written in a book or written in a rough paper. Then represent the number. So instead of 9, you write 1001. Instead of 5, you write 0101. Instead of 8, you write 1000. That is representation. Don't confuse. Okay, so
should we memorize this one?
Sorry?
Should we memorize this thing? Should we memorize this?
Yeah, you have to memorize that. Actually, the memorizing is not difficult. No, that is for the first 9, first 10 hexadecimal, first 9 hexadecimal table content, the same. So nothing big to memorize. So, but anyway, it has the 4-digit code, okay, and it is anyway the binary value. The other hand, 9 means 9 divided by 2, write the remainder. What is the value? It is 4 remainder 1. Again, divide by 2, write the remainder. 2 remainder 0. Divide by 2, write the remainder. 1 remainder 0. It's also 1001. Right? Anyway, after dividing, the value is placed on, but using 4 digits. That 4 digit is must. 0